Hi, my name is Nicholas Espinal. This is the 8th question on my Chapter 28 quiz, and this is what it asks. A tube with a 3 mm radius has ions flowing through it along its length. To determine the rate at which the charge is being moved through the tube, the magnetic field just outside the tube is measured and found to be 44 times 10 to the negative 4 teslas. If the only contributor to the magnetic field is the moving ions, and if the walls of the container are very thin and do not screen magnetism, what is the magnitude of the current flowing through the tube? They give us mu sub 0, and these are our answer choices. So given the situation that we're being told, we should make a note of a few things. So they're telling us that it's a tube with passing ions, and this is going to provide some type of current, and that the walls of this tube are thin and do not screen magnetism. So that means that the magnetism, the magnetic fields are going to be flowing through this, right through the tube, and that the passing ions are essentially going to be representing current. And this cross section here is that representation of all of those passing ions. It's really just current. So in this perspective, outside of the tube can be interpreted really as a thin wire with current. So if we can interpret it as a thin wire, just like the rest of our problems that we see in chapter 28, then we can use equations or formulas that we find to find the magnetic field. We know that there's a formula for the magnetic field for a wire with current that's equal to the mu sub 0 times the current, all divided by 2 pi divided by the distance from the point of observation to the wire. And since we know the magnetic field and desire the current instead, we can manipulate the equation that we have here, and we'll be able to find the current instead. So the current would be the magnetic field times 2 pi r all over mu sub 0. So we have this equation, and we know the magnetic field. They gave that to us. We know the radius of the tube, which is really the point of observation there, and we also know mu sub 0. So we could input all of these values and solve for the current. When we input all of these values, the current is going to be 66 amps, and we look at our answer choices here, and we see that the second choice is the correct answer. Thank you.